All right, let's talk about something that I think every single AI engineer is dealing with right now. How do you go from that super cool demo you hacked together over a weekend to a real, actual product? Something that can survive out in the wild. Well, we've got the playbook, so let's get right into it. You know that feeling, right? A couple of API calls, some clever prompting, and bam, you've built something that feels like straight-up magic. Honestly, getting that first version working is easier than it's ever been. But here's the kicker. The path from that cool demo to a durable, lasting business is an absolute minefield. And the skills that got you that initial wow moment, they're not the same skills that are going to help you survive long-term.
So this brings us to the first and maybe the most important question you've got to ask yourself. What's your defense? What's your moat? In a world where these incredibly powerful foundation models are basically available to everyone, what's to stop a giant competitor from just absorbing your idea and rolling it out to their billion users? This is the core strategic problem you have to solve.
And this quote right here, this is the ghost that haunts every AI founder's dreams. It's a brutal question, but you have to face it. If your thing starts getting traction, what actually prevents a behemoth like Google from assigning a few engineers to build it in 2 weeks and then just ship it for free?
Now, what I love about this is how it breaks down the fight. On technology, believe it or not, the playing field is kind of level. We're all using similar foundation models. Distribution, yeah, okay, big tech absolutely crushes us there. But look at that last row. Data. That is your battleground. While they have these huge generic data sets, a startup's winning move is to get to market fast and start collecting specific usage data that nobody else has. That data, that becomes your defensible moat.
And hey, before you get discouraged, you have to remember this. History is packed with companies that looked like simple features, but ended up winning because they out-executed the giants. I mean, Calendly, MailChimp, Photoroom, they all started in the shadow of a much bigger product, but they obsessed over doing one thing exceptionally well for a very specific audience. So the key takeaway here is it absolutely can be done.
Okay, so let's shift gears from business strategy to the down and dirty engineering reality. You've got your idea, you've got a plan for your moat. Now you actually have to build the thing. And this is where so many projects slam into the wall of the treacherous last mile. That final stretch where progress just suddenly slows to an absolute crawl.
If you've ever felt this pain, I promise you, you are not alone. This isn't just a feeling. It's a documented, well-known phenomenon in AI development. That first bit of progress you get from a foundation model feels incredible, right? But getting from a pretty good demo to a rock-solid product that users can actually depend on, well, that's a whole different ballgame.
And this chart just illustrates the point perfectly with real-world data from LinkedIn. It took their team just 1 month to get 80% of the way there. That's fantastic. But look at the next bar. It took them 4 more months just to get another 15%. That's the last mile in action. That's all the time you spend wrestling with edge cases, fighting hallucinations, and polishing all those little imperfections that separate a cool toy from a professional tool.
So this new reality of building on top of these giant, pre-existing models, it demands a new kind of engineer. The core ideas of machine learning are still there, of course, but the day-to-day job has completely changed. So what really is the difference between classic ML engineering and this new world of AI engineering?
Here it is in a nutshell. Traditional ML engineering was all about building models from the ground up. You were obsessing over architectures, training pipelines, all that stuff. Modern AI engineering, on the other hand, is much more about adapting models that somebody else has already spent billions of dollars to build. The focus has moved up the stack, from creation to application.
Okay, so if adaptation is the name of the game now, what are the primary plays we can run? For any AI engineer building products today, it really boils down to 2 fundamental techniques. Let's break down your toolkit.
First up is prompt engineering. This is probably where you started. You're basically guiding the model, teaching it what you want through the input you give it. Instructions, examples, context. The really crucial thing to remember here is that you are not changing the model itself. You're just talking to it. Its internal weights stay exactly the same.
The second tool is fine-tuning, and this is a much deeper level of adaptation. Here, you're actually continuing the training process using your own specialized data. And the key difference, and it's a big one, is that this process actually updates the model's weights. You are fundamentally changing the model's brain to make it better for your specific task.
So when do you use which tool? This table makes it pretty clear. Prompt engineering is your go-to for low complexity when you don't have a lot of data and for really rapid experiments. It's fast, it's agile, it's relatively cheap.
Fine-tuning, on the other hand, is your heavy-duty option. It's more complex. It needs more data and compute, but it is absolutely essential for those highly specialized, domain-specific tasks where prompting just isn't going to cut it.
All right, finally, let's talk about what happens after you launch. In traditional software, you might ship a feature and kind of move on. But in AI, launching is just the beginning. You are basically committing to riding a bullet train of progress, and you have to build your entire product to withstand that incredible speed.
And this slide shows you exactly what that bullet train looks like. I mean, in just 2 years, the cost to run these models has plummeted, while the performance has just skyrocketed. What was state-of-the-art and super expensive last year is now commonplace and cheap this year, and that is both an incredible opportunity and a massive engineering challenge.
Which leaves us with this final, critical question. The brilliant model you integrate into your product today might be the wrong choice in 3 months. So the ultimate measure of a truly defensible AI product isn't just the quality of your model right now, but the agility of your engineering stack to adapt to the better, cheaper, faster models of tomorrow. So you have to ask yourself, is your stack ready for that?